In this lecture, we will discuss regarding atmosphere. So, in relation to atmosphere, we will discuss the very structure of atmosphere in the introduction, then the very composition of atmosphere. So, our planet Earth is involved by a deep blanket of gases extending several thousands of kilometers above its surface. This gaseous cover of the earth is known as the atmosphere. Like land, lithosphere, and water, hydrosphere, the atmosphere is an integral part of the earth. Compared to the Earth's radius, the atmosphere appears to be only a very thin layer of gases. However, because of the force of gravity, it is inseparable from the Earth. The atmosphere differs from the lithosphere and the hydrosphere in many respects. Air is a colorless, odorless, and tasteless substance. Besides being mobile, elastic, and compressible, it is only when air moves horizontally as wind that we feel its presence. The air also exerts pressure on Earth's surface by virtue of its weight. This pressure is called atmospheric pressure. Atmospheric pressure is the most important climatic element. The atmospheric pressure at sea level is only 1034 gram per square centimeters. And now we'll discuss regarding the very composition of atmosphere. Atmosphere is a mixture of many gases. In addition to it contains huge numbers of solid and liquid particles. Some of the gases may be regarded as permanent atmospheric components which remain in fixed proportion to the total gas volume. Other constituents vary in quantity from place to place and from time to time. If the suspended particles, water vapor, and other variable gases were excluded from the atmosphere, then the dry air is very stable all over the earth up to an altitude of about 80 kilometers. Nitrogen and oxygen make up nearly 99% of clean dry air. The remaining gases are mostly inert and constitute about 1% of the atmosphere. Besides these gases, large quantities of water vapor and dust particles are also present in the atmosphere. The solid and liquid particles are of great climatic significance. So now we will discuss regarding the very structure of atmosphere, such as troposphere, Stratosphere, Ozonosphere, Mesosphere, Ionosphere, and Exosphere. So, in particularly, troposphere is the atmospheric layer between the Earth's surface and an altitude of 8 kilometers at the poles and 18 kilometers at the equator. The thickness is greater at the equator because the dead air rises to greater heights. The troposphere ends with tropopause. The temperature in this layer as one goes upward falls at rate of 6.5 degrees centigrade per kilometer and reaches minus 45 degrees centigrade at the poles and minus 80 degrees centigrade over the equator at tropopause. Troposphere is marked by temperature inversion, turbulence, and it is also meteorologically the most significant zone in the entire atmosphere. It is also called the convective region, since all convection stops at tropopause. The troposphere is the theater for weather because all cyclones, anticyclones, storms, and precipitation occur here, as well as water vapors and solid particles lie within this. The troposphere is influenced by seasons and jet streams. The second structure of atmosphere is the stratosphere. It lies beyond tropospheres up to an altitude of 50 kilometers from the Earth's surface. The temperature in this layer remains constant for some distance but then rises to reach a level of 0 degrees centigrade at 50 kilometer altitude. This rise is due to the presence of ozone. Sometimes cirrus clouds are present at lower levels in this layer. And now we'll go to the third structure of atmosphere, and that is Ozonosphere. It lies at an altitude between 30 kilometers and 60 kilometers from the Earth's surface and spans the Stratosphere and Mesosphere. Because of the presence of ozone molecules, this layer reflects the harmful ultraviolet radiation. The Ozonosphere is also called as because a lot of chemical activities goes on here. The temperature rises at a rate of 5 degrees centigrade per kilometer through the Ozonosphere. Now we'll go to the fourth structure of atmosphere, and that is Mesosphere. This is an intermediate layer beyond the ozone layer and continues up to an altitude of 80 kilometers from the Earth's surface. The temperature gradually falls to minus 100 degrees centigrade at 80 kilometer altitude. And now we'll go to the fifth structure of atmosphere, that is Ionosphere. This layer is located between 80 kilometer and 400 kilometer and is an electrically charged layer. This layer is characterized by ionization of atoms because of the electric charge. Radio waves transmitted from the earth are reflected back to the earth by this layer. Temperature again starts increasing with height because of radiation from the sun. And the sixth structure of atmosphere is Exosphere. This is the uppermost layer of atmosphere extending beyond the Ionosphere above a height of about 400 kilometers. The air is extremely rarefied and the temperature gradually increases through the layer. So now we'll go to temperature. What exactly temperature means and the very introduction relating in defining temperature, then those factors which are responsible regarding the very temperature of earth is sun rays, duration of sunshine, transparency, land sea differential, then winds, then slope, ocean currents, and altitude. So what exactly temperature? Because of the small size of the earth compared to the sun and the great distance between the two as exactly 149 million kilometers. Only a minute percentage of solar radiation 1 in 2 billion parts is intercepted by the earth, but even the small amount of solar radiation reaching the earth is of great significance. All biological and many of the physical phenomena of the earth are controlled by this teeny proportion of solar radiation. The incoming solar radiation is known as insolation. It is received in the form of short waves which are of electromagnetic in nature. These short waves of ultraviolet rays are absorbed partly by the atmosphere and on reaching the earth are converted into long wave radiation by reflection. The Earth's surface receives this radiant energy at the rate of 2 calories per square centimeter per minute. So now we'll discuss those factors affecting distribution of insolation or temperature. So the amount of insolation reaching the Earth's surface and its effectiveness per unit area depends on the factors such as the sun's rays, the angle of incident or the angle which the sun rays make the Earth's surface determines the amount of solar radiation which a particular place on the earth will receive. A smaller single means the same amount of radiation will have to serve a large area on the earth and the intensity will be less concentrated. A larger angle means the sun's rays will be nearly vertical over the place and the given amount will have to serve a smaller area. As a result, the radiation received will be more concentrated and the intensity will be greater. For instance, at 45 degree latitude, the amount of radiation received is only 75% of what is received at the equator. At the Arctic or Antarctic circles and at the North Pole and South Pole, this figure is 50% and 40% respectively. And the second factor is depending on the duration of sunshine. The amount of solar radiation received obviously depends on the length of time that the sun shines over a particular place. At the equator, where the duration of sunshine is 12 hours daily throughout the year, the amount of radiation received is more compared to the other places on the earth. At winter solstice on 22nd December, the southern hemisphere receives more sunshine as it is summer there, while at summer solstice on 21st June, the northern hemisphere receives more sunshine as it is summer time there. And the third important factor, that is relating to transparency of atmosphere, the amount of cloud cover and its thickness, dust and water vapor, which determine the transparency of the atmosphere, affect the reflection, absorption and transmission of solar radiation. If the wavelength of the radiation is more than the radius of the obstructing particles such as a gas, then scattering of radiation takes place. If the wavelength is less than the obstructing particles such as a dust particle, then total reflection takes place. Absorption of solar radiation takes place if the obstructing particles happen to be water vapor, ozone molecules, carbon dioxide molecules or clouds. Now we'll go to the next important factor, that is land-sea differential. The temperature of the air resting over a landmass differs markedly from that of the air resting over an expanse of water in the same latitude. Reflection is more by land than by sea. Especially snow-covered areas reflect up to 70% to 90% of insolation, average penetration of insolation, and therefore heat is more in water up to 20 meters than in land where it is up to 1 meter only. Therefore land cools more rapidly. The specific heat of water is 2.5 times higher than landmass. Therefore water takes longer to get heated up and to cool down. The currents, tides and drifts exist only in oceans which carry the heat to lower layers. The next factor, that is the prevailing winds. The oceanic winds have the capacity to take the moderating influence of the sea to coastal areas, reflected in cool summers and mild winters. This effect is pronounced only on the windward side. The leeward side or the interiors do not get the moderating effect of the sea. Therefore, experiences extremes of temperature. Another important factor is regarding the very role of slope. The direction of the slope and its angle control the amount of solar radiation received locally. Slopes more exposed to the sun receives more solar radiation than those away from the sun's direct rays. In many valleys, settlements and cultivation area therefore concentrated on southern slopes, whereas northern slopes remain forested. In our country, this phenomenon is well observed in the Himalayan region. And the next important factor is the ocean current. Ocean currents influence the temperature of adjacent land areas considerably. Warm currents raise the temperatures of the coastal areas, whereas cold currents lower them. For instance, in higher areas such as the latitudes, the eastern coast have much lower temperature than the western coast due to the influence of cold currents. Similarly, the North Atlantic drift and extension of the warm Gulf Stream keeps winter temperature in Great Britain and much of Western Europe warmer than would expect for their latitudes. Because of the prevailing westerly winds, the moderating effect of the ocean currents are carried far inland. The influence of the cold currents is most pronounced in the tropics or during the summer months in the mid latitudes. For instance, the cold Bengali current of the western coast of southern Africa moderates the tropical heat. And finally, the last important factor that we would discuss is regarding altitude. Altitude has a direct effect on prevailing temperatures. This is because the lower layers of the atmosphere are compressed under atmospheric pressure and are closer to Earth's surface. It makes them warmer than the layers at higher levels. Thus, as we go higher, the temperature gradually decreases and the air becomes cooler. The normal lapse rate is roughly 1 degree centigrade for every 165 meters of ascent. There are variations from the normal at different times of the day, in different seasons and in different location of places. For instance, the two cities in Ecuador